transformer utilization in center tap type of full wave rectifier. So here we are interested to calculate the TUF when we are using the full wave rectifier with the center tap type of configuration. The interesting thing is that here actually the transformer is utilized in a very efficient way. Means I'm not saying the value of TUF is high, but here we know, if you remember the circuit, here is the circuit I have. Here you can see we are applying the AC here, and then the secondary we are having center tappings during positive half cycle D1 conduct, during negative half cycle D2 conduct. This all theory you should be knowing. This diagram I am only just showing as a reference, right? Now let us go back to our own our actual equation of TUF. Now here we can go through the line. Here the average TUF is calculated by, here the average TUF is calculated by considering the primary and secondary winding separately. It means that we will calculate the TUF of primary, and then we'll calculate the TUF of secondary, and then we will calculate the average of it. Okay. Now again, another thing is that the primary winding carries the current continuously, while the secondary current flows through each half separately in every half cycle. What is the meaning of this? Meaning is very simple. We know that while discussing the working of this circuit, we discussed is very well that what happens during positive half cycle, only the current is carried by upper portion of this winding. During negative half cycle, it is carried by the lower portion. So this is as far as the secondary is concerned. But what about primary? In primary there is always a current, whether it's a positive half cycle or negative half cycle. So that was the meaning of this, that the primary winding carries the current continuously, while the secondary current flows through each half separately during each half cycle. Okay. Now after this, let us see what is the next point. Next point is that each secondary is associated with one diode. This is just similar to the secondary of half wave rectifier. The meaning is that we know, if we consider this circuit and if we look it like this, so here you can see it is nothing but the transformer, one diode and one resistor. So this is nothing but a half wave rectifier. If you do like this, we can see here it is a transformer, one diode and one resistor. So this is nothing but two half wave rectifiers connected back to back. So that is the meaning of that statement. So that's why what we can do, we can have the equation like this. The transformer utilization of the secondary is twice the transformer utilization of the half wave rectifier, because we have just now seen that the secondary of center tapping means this configuration is nothing but the two half wave rectifiers connected back to back. That's why the equation can be, this is the equation for secondary only. Remember this, we have to go for the secondary and primary separately. First we'll go for secondary, then I will show the equation for the primary. So for secondary, TUF means TUF of secondary is twice the TUF of half wave rectifier. And now if you remember, we have calculated the TUF of the half wave rectifier earlier, just before this lecture we have calculated and we got this value, right? So you can once again, if you want, you can go through the video once again. So I will put the values directly here. So here it is 2 into TUF of the TUF of half wave rectifier. So that value is 2 into, if you remember, it is 0.287. So in that way, the TUF of secondary in case of the center tap type of full wave rectifier comes to be 0.574. But remember, this is the TUF of secondary. In the same manner, we have to go for TUF of primary, as it is written here. We have to calculate TUF of primary and TUF of secondary separately, and then we have to take the average. Once again, you should remember. So that's why let us calculate the TUF of primary, right? So now TUF of primary, we should be remembering the equation of transformer utilization factor. In the previous lecture we have given, it is nothing but PDC divided by the PAC rating of the transformer. So PAC rating is also called as the VA rating of the transformer, that is voltage into current, which is nothing but the power. VA rating of transformer, and here as we are interested in the primary, that's why I am writing VA rating of transformer primary, right? So now this PDC, we should at this stage, now as we have gone through number of equations, you should be remembering some values at least. So PDC is nothing but IDC square into RL, means power is nothing but I square into R. So which I we should take, as it is a DC power, so I should take the DC current. So that's why it is IDC its square into RL, right? And divided by VA rating of the transformer primary. Now if we are talking about the primary, what should be the RMS value of voltage? So RMS value of voltage will be Vm by root 2. Now this is clear na, Vm by root 2. Also, as this is the full wave, so that's why the RMS current will also be Im by root 2. So this is nothing but RMS voltage multiplied by RMS current. So V into I is nothing but the power. So this is the PDC and this is the PAC, right? Now after this, if you want, we can put the equation of this Vm in terms of Im, because this term we can get in terms of Im. This is already Im, so if I convert this term into Im, so it will be easy to calculate. So that's why what I can write here is TUF of primary is equal to, now instead of IDC, what I can write, I will write the equation of IDC for full wave rectifier in terms of Im. And if you remember, in full wave rectifier, IDC is equal to twice Im by pi. So that I am writing here, it is twice Im by pi. Now it's a square, that's why it is in bracket and it's a square, multiplied by resistance RL. Okay. After that, this Vm can be written in terms of Im, like Vm is nothing but Im multiplied by load resistor. If you do not remember, kindly go through the previous video where we have written this thing. So instead of Vm, I am writing Im multiplied by RL. So this I have written, now divided by root 2 as it is. Further, this term Im divided by root 2. Okay, now let us solve this. So this is not a big thing to solve. So just I will, okay, so 2 is a square, so it is 4, then Im square divided by pi square multiplied by RL divided by, now this is Im, so again it is Im square, under root 2 it is 2, and what remaining is RL. So in this way it is RL. So after solving this, finally what I will get, it is nothing but the 8 by pi square. Further solving this, it comes to be 0.812. Okay, so now once again let us see what actually we have calculated. We have calculated the TUF of primary, means transformer utilization of primary of the, means primary of that circuit. Means what is actually this meaning, this its meaning is how much percentage value we are utilizing this primary. So that is TUF of primary. Okay, this is so this is only value for the primary. In the same manner, we have calculated TUF of secondary, means this, and now let us go for its average. Why average? Because initially we have written that average TUF is calculated by considering primary and secondary winding separately, and that's why the TUF average in case of center tap type of full wave rectifier is given by TUF average is equal to TUF of primary plus TUF of secondary and its average, so it will be divided by 2, right? And that's why let us take the average of this two. So it is nothing but 0.8 this value 0.812 plus this value 0.574 and this whole thing divided by 2. So just you calculate this thing, and what you will be getting, the TUF average in case of center tap full wave rectifier is nothing but it's after doing this calculation I am getting the value to be 0.693. So this is the value in case of this is the value of TUF in case of center tap type of full wave rectifier. And you can see it is improved. In case of half wave rectifier, the value was 0.287, right? In case of center tap full wave rectifier, it is 0.693. So it is better utilization of transformer as far as the half wave rectifier is concerned.